Picture yourself 25,000 feet above Belgium on a spring morning in 1943. You're a German fighter pilot, one of the best in the world, flying a machine you know intimately. You fought over the English Channel, tangled with Spitfires, survived encounters with hurricanes. You know what victory looks like, and you know what defeat smells like. Then you see them approaching from the west, and you can't quite believe your eyes. They're massive, absolutely enormous. You've never seen single-engine fighters this large. The nose is bulbous, swollen with what must be the largest radial engine you've ever encountered on a fighter aircraft. The fuselage behind it looks bloated, far too thick for a proper interceptor. The wings seem disproportionately small for the body they're supporting. Everything about these machines screams wrong to your trained eye. You reach for your radio transmitter, trying to keep the disbelief out of your voice as you describe what you're seeing to your wingman. The Americans have arrived with something that looks more like cargo aircraft than fighters. You roll into attack position. Why wouldn't you? These things look like they'll be easier targets than the bombers you've been intercepting. Your Focke-Wulf is tight, responsive, deadly. You've been flying this type for months now, and you trust it completely. Whatever these American contraptions are, they can't possibly match your maneuverability. This should be straightforward. Within half a year, everything you think you know about aerial combat will be turned upside down. Within 12 months, your squadron will be developing specific tactics just to avoid these monsters under certain conditions. Within 2 years, pilots throughout the Luftwaffe will speak about them with grudging respect tinged with fear. By the time the war ends, these ungainly beasts will have been responsible for destroying 9,000 locomotives across occupied Europe, more than any other fighter type on either side. They'll have crippled Germany's ability to move troops, supplies, and ammunition at precisely the moment when mobility meant the difference between organized resistance and collapse. This is about the heaviest single-engine fighter ever committed to combat in the European theatre. This is about how mockery transformed into dread. This is about how an aircraft designed for one specific mission discovered its true purpose, doing something entirely different. This is about how every single characteristic that made experienced pilots laugh became exactly what made it unstoppable. The question isn't simple, and the answer is even more complex. How did something that violated every principle of fighter design become the weapon that destroyed Germany's transportation infrastructure? To understand that, we need to go back to the beginning, before the first Thunderbolt ever flew over Europe. Back to the assumptions both sides held about what made a fighter effective in modern warfare. By spring of 1943, when the first of these American behemoths touched down in England to join the 8th Air Force, the rules governing aerial combat seemed carved in stone. 5 years of continuous warfare had taught lessons written in the blood of thousands of pilots. Everyone knew what worked and what didn't. Speed was important, certainly, but maneuverability mattered even more. A proper fighter should be relatively light, instantly responsive to pilot input, capable of executing tight turns at medium altitude where most engagements occurred. The Supermarine Spitfire embodied everything the doctrine demanded. It weighed just over 6,000 pounds without fuel or ammunition, featured those beautiful elliptical wings that had become iconic, and could turn inside anything the Germans flew. The Messerschmitt 109 represented German thinking along parallel lines. It was a lightweight design, optimized for rapid climb rates and instantaneous turn performance. Both designs reflected hard lessons, learned during the Battle of Britain in 1940 and 41. Fighter Command had discovered, through bitter experience, that pilot survival depended overwhelmingly on the ability to outturn your opponent. Success meant bringing your guns to bear during the chaotic swirl of a turning fight. It meant climbing quickly back to altitude after each engagement to maintain energy advantage. The Luftwaffe had learned identical lessons, adding their own refinements based on combat over Poland, France, and Russia. By 1943, both air forces had reached consensus. The ideal fighter was nimble, relatively light, with handling qualities and rate of climb optimized for combat altitudes between 10 and 20,000 feet. Then the Americans arrived with something completely different, something that made experienced pilots do double takes, something that seemed to violate every principle everyone had agreed upon. The Republic P-47 Thunderbolt weighed 10,000 pounds empty, fully loaded with fuel, ammunition, pilot, and equipment. It could exceed 17,500 pounds. That made it heavier than some light bombers operating in the theatre. Think about that for a moment. A single-engine fighter weighing more than a twin-engine bomber. It seemed absurd. The power plant was a Pratt & Whitney R2800 double Wasp, 18 cylinders arranged in 2 radial rows, producing 2,000 horsepower, driving a propeller 13 feet in diameter. The engine alone weighed 2,400 pounds, more than the entire empty weight of some fighters. To provide ground clearance for that enormous propeller, Republic Aviation's engineers had designed telescoping landing gear that extended 9 inches as the wheels came down. More complexity, more weight, more things that could go wrong. The fuselage was massive because it had to be. Behind the pilot sat the turbo supercharger system that gave the aircraft its high-altitude performance. This was a complex arrangement of ducts, intercoolers and wastegates that fed compressed air to the engine at altitudes where other fighters gasped for oxygen. Exhaust gases from all 18 cylinders were collected and routed through pipes along each side of the cockpit to drive a turbine spinning at 21,300 revolutions per minute at full power. At maximum output, those exhaust pipes glowed cherry red. The whole system required cooling air, oil cooling, intercooling, all of which meant more ducting, more weight, more bulk. When the first examples arrived at Royal Air Force bases in England during January of 1943, British pilots who had spent years flying Spitfires looked at them with something between horror and fascination. The Thunderbolt's wingtip stood higher than a Spitfire's cockpit canopy. The cockpit itself was so spacious that pilots joked they could unbuckle their harnesses and walk around inside during flight. One pilot compared the experience to flying a bathtub around the sky. The Spitfire. Mark V they'd been flying had a wingspan 5 feet shorter, roughly 1/4 less wing area, approximately 1/4 the fuselage volume, and weighed about half as much as a fully loaded Thunderbolt. German intelligence officers, examining reconnaissance photographs of the new American fighter, reached similar conclusions. Here was an aircraft that violated fundamental principles everyone agreed upon. Too heavy to turn with a Messerschmitt, too large to be nimble in combat, probably adequate for escorting bombers at high altitude where maneuverability mattered less, but certainly not threatening in the kind of fluid, swirling dogfights where the Luftwaffe had established its dominance. What neither the British nor the Germans understood was that the aircraft's design reflected a completely different set of assumptions about air warfare. These weren't assumptions developed from European combat experience. They came from clear-eyed analysis of what would be required to fight a war across the Atlantic Ocean. In 1940, as the Battle of Britain raged and France fell, Republic Aviation's chief engineer Alexander Kartveli sat in his office in Farmingdale, New York, studying intelligence reports about combat in Europe. He was making calculations about distance, altitude, and industrial capacity. The conclusions he reached would shape everything about the aircraft he was designing. The Americans would not be fighting over their own territory. They would be flying from England deep into occupied Europe and Germany itself. Range wasn't optional. It was the entire mission. The ability to escort bombers to targets 400, 500, 600 miles from base, then return home was absolutely critical. High-altitude performance was equally important because the bombers would be operating at 25 to 30,000 feet, and their escorts needed to be effective at those altitudes. Protection mattered tremendously because aircraft lost over enemy territory meant trained pilots captured or killed, and those pilots took months to replace, even if the industrial system could produce replacement aircraft in weeks. Kartveli's solution was radical by European standards. Instead of trying to match European fighters in turning performance, he would build a fighter optimized for high-altitude combat that could outdive anything in the sky, that could sustain damage no lightweight fighter could survive, and that carried enough fuel for deep penetration missions into the heart of Germany. The result violated every aesthetic principle of fighter design that had evolved over the previous decade. It was objectively ugly. No one could argue otherwise, but it was also exactly what the mission required, even if nobody fully understood that yet. The Pratt & Whitney R2800 engine wasn't chosen for its lightweight. Obviously it wasn't light. It was chosen because it was reliable, because it was air-cooled and thus had no vulnerable coolant system that could be punctured by a single bullet, and because it could produce enormous power. That 18-cylinder radial engine sitting in front of the cockpit like a shield could absorb punishment that would have destroyed the inline liquid-cooled engines in a Spitfire or Messerschmitt. Pilots would discover through hard experience that they could lose cylinders, have them literally shot away by cannon fire, and the engine would keep running, rough, vibrating badly, but functional enough to bring them home. The turbo supercharger system added tremendous weight and complexity, but it gave the aircraft capabilities no other fighter possessed. At 30,000 feet, where the air was thin and other fighters struggled to maintain power, the Thunderbolt was still fast and responsive. The supercharger compressed that thin air, feeding the engine the oxygen it needed to maintain power at altitude where the enemy couldn't follow. This meant that in the high-altitude bomber escort role, the aircraft could outperform anything the Luftwaffe sent up to intercept. If a German fighter got on a Thunderbolt's tail at altitude, the American pilot had an option no one else possessed. He could push the nose down and dive. The laws of physics were unforgiving but predictable. The Thunderbolt's weight, which made it sluggish in turns, became a tremendous advantage in a dive. It fell like a stone, but a controlled stone, accelerating past 500 miles per hour, faster than any Messerschmitt or Focke-Wulf could follow without tearing itself apart. German pilots quickly learned that chasing a diving Thunderbolt was suicide. Their lighter fighters would either come apart structurally, trying to match the acceleration, or they would simply be left behind as the American pilot built up speed, leveled out at lower altitude, and escaped before they could catch up. The very characteristic that looked like a weakness, all that weight, became a tactical advantage that German pilots learned to respect and eventually fear. But in April of 1943, as Werner Schroer and his wingmen closed on those first formations of Thunderbolts over Belgium, none of this was yet understood by anyone. The German pilots saw only what looked wrong. The bulk, the weight, the graceless lines. They had no way of knowing they were looking at an aircraft that would rewrite the rules of aerial warfare in ways nobody could yet imagine. The 4th Fighter Group took their Thunderbolts into combat for the first time on March 10th, 1943. The mission was a fighter sweep over France, a simple patrol designed to familiarize pilots with their new aircraft and probe German reactions. It turned into a disaster, but not the kind anyone expected. Radio malfunctions left pilots unable to communicate with each other or with ground controllers. The Thunderbolts felt sluggish at medium altitudes where the sweep occurred. Pilots accustomed to the Spitfire's instant response found themselves wrestling with controls that seemed heavy and unresponsive. They returned to England discouraged, wondering if they'd been given inferior equipment. Some wondered if this was America's idea of a joke. The radios were fixed quickly, replaced with British sets that actually worked properly. Then on April 15th, Major Don Blakesley scored the Thunderbolt's first confirmed aerial victory, shooting down a Focke-Wulf 190. The kill was instructive for everyone paying attention. Blakesley hadn't tried to outturn his opponent. That would have been suicide. He'd used altitude advantage and diving speed to position himself for a single devastating attack run. The 850 caliber machine guns in the Thunderbolt's wings, firing armor-piercing incendiary rounds at a combined rate of over 100 rounds per second, had torn the German fighter apart. The Focke-Wulf hadn't exploded or burned dramatically. It had simply disintegrated under the weight of fire, pieces of wing and fuselage separating and tumbling through the air. Over the following months, American pilots developed tactics that played to the Thunderbolt's strengths while avoiding its weaknesses. They stayed high, typically at 28 to 32,000 feet, where their turbo-supercharged engines gave them superiority over any German fighter. From that altitude, they watched for threats and opportunities like hawks circling above prey. When they spotted enemy aircraft below, they didn't descend into turning fights. That was the old way, the European way, and it would get you killed in a Thunderbolt. Instead, they dove, building speed until they were moving faster than anything else in the sky. They made a single high-speed attack pass, guns blazing for perhaps 2 seconds, then used their momentum to climb back to altitude before the Germans could react. If a Messerschmitt or Focke-Wulf got behind them during an engagement, they didn't turn to fight. They pushed the nose down and dove away, escaping at speeds the German fighters couldn't match without risking structural failure. German pilots adapted too, but their adaptations revealed their growing respect for the Thunderbolt rather than contempt. Kurt Bulligan, a Luftwaffe ace who would finish the war with 112 victories, developed a specific counter-tactic. He explained it in post-war interviews with unusual candor. The Thunderbolt was very heavy, too heavy for some maneuvers. We would see it coming from behind and pull up fast, and the Thunderbolt couldn't follow that kind of rapid climb. Then we came around and tried to get on its tail this way. Notice the careful language. It worked sometimes, not always, not even usually, just sometimes. And it required the German pilot to spot the Thunderbolt early, execute the maneuver perfectly, and hoped the American didn't simply dive away before the German could complete his turning reversal. It was a technique born of necessity and respect, not confidence and superiority. By mid-1943, the Thunderbolt had proven itself as an escort fighter beyond anyone's initial expectations. The 56th Fighter Group, led by Lieutenant Colonel Hubert Zemke and later by Lieutenant Colonel Francis Gabreski, became legendary flying these massive machines. They developed aggressive tactics, pushing their aircraft to its limits, and racked up impressive kill tallies that shocked German intelligence analysts. Gabreski himself would score 28 confirmed aerial victories, every single one in Thunderbolts. Captain Robert Johnson scored 27. These weren't pilots compensating for inferior equipment. They were pilots exploiting advantages that European combat doctrine hadn't anticipated, because European combat doctrine had been developed for a different kind of war. But the Thunderbolt's true impact on the European war wouldn't come from high-altitude fighter combat, impressive as that was. It would come from a role no one had originally envisioned for this massive aircraft, a role that would transform it from a good escort fighter into something far more devastating. In late 1943, as Allied planners prepared for the invasion of France, they faced a critical question that kept them awake at night. How could they prevent German armoured divisions from reaching the Normandy beaches quickly enough to throw the invasion back into the sea? The initial landings would be vulnerable, desperately vulnerable, until enough forces could be established ashore. If German panzer divisions could reach the beaches within 24 to 48 hours, the invasion might fail catastrophically. The answer involved bombing French rail yards and bridges, certainly. Strategic bombing had been underway for months, but it also required something more immediate and flexible. They needed aircraft that could hunt German transportation at low altitude, attacking trains and trucks wherever they appeared, cutting supply lines faster than the Germans could repair them. They needed flying interdiction, constant and relentless. For this mission, lightweight fighters like the Spitfire and Messerschmitt were poorly suited, flying at treetop level through intense anti-aircraft fire, taking direct hits from 20mm and 37mm flak guns, required an aircraft that could absorb tremendous punishment and keep flying. The Thunderbolt, with its massive radial engine serving as frontal armor, its robust airframe, its redundant systems, turned out to be almost ideally suited for this brutal work. Nobody had planned it that way. It was a happy accident of design. In March of 1944, Major Glenn Duncan of the 353rd Fighter Group began operational tests of low-level strafing and dive-bombing tactics. The results exceeded even optimistic expectations. The Thunderbolt could deliver devastating firepower against ground targets and survive the kind of battle damage that would have destroyed any other single-engine fighter in Europe. It could take hits that would doom a Spitfire or Messerschmitt and still bring its pilot home. The campaign against German railways began in earnest during April and May of 1944 as part of the transportation plan designed to isolate Normandy from German reinforcements. 9th Air Force Thunderbolts operating from bases in England flew armed reconnaissance missions across France, seeking targets of opportunity wherever they could find them. Locomotives became priority targets, and for good reason. Each working locomotive could pull dozens of railcars loaded with troops, tanks, ammunition, or fuel. Destroy the locomotive, and the entire train was immobilized, stranded wherever it happened to be. Destroy enough locomotives, and Germany's ability to move military forces would collapse entirely. It was mathematical, cold-blooded, and brutally effective. Flying these missions required a specific technique that pilots learned through experience and shared through squadron briefings. You wanted to approach fairly low, maybe 2,000 feet, so your angle of dive on the train was quite shallow. You didn't want to come down at a 45-degree angle, because that meant you had to start pulling out earlier to avoid smashing into the train, and you'd have less time with your guns on target. The ideal attack profile involved approaching at about 2,000 feet, identifying the locomotive, which in steam engines meant spotting the tender car filled with coal or water, then descending to 300 to 500 feet for the gun run, aiming directly at the boiler. The 50 caliber machine guns could fire two types of ammunition loaded in alternating belts: standard ball ammunition and armor-piercing incendiary rounds. Against a locomotive boiler filled with superheated steam at high pressure, the effect was catastrophic. Armor-piercing rounds would penetrate the boiler casing, and what happened next was devastating. The steam would explode outward in massive bursts that often killed the crew instantly and rendered the locomotive completely irreparable without return to a major workshop. The incendiary component would ignite coal, wooden components, and sometimes ammunition if the train was carrying military supplies. A 2-second burst from all 8 guns, about 160 rounds total, was usually sufficient to destroy a locomotive completely. Just 2 seconds of fire could eliminate a critical piece of German transportation infrastructure. But German defenders adapted quickly, as they always did. Initially, trains ran during daylight with minimal protection. After Thunderbolts began their campaign in earnest, the Germans added anti-aircraft cars to trains. These were flat cars mounting 20mm or 37mm automatic cannons positioned at the front, middle, and rear of important military trains. These flat cars were manned by experienced gunners who learned to watch the skies constantly and open fire the instant an aircraft appeared on the horizon. Let's see, tracers from a 37mm gun travelled at nearly 3,000 feet per second and could reach a Thunderbolt at low altitude in under half a second. There was no time to dodge. Pilots attacking trains flew through curtains of fire, taking hits with every attack run. Some pilots compared it to flying through a steel rain. You just accepted that you were going to get hit and hoped nothing vital got damaged. Colonel Leo Moon, commanding officer of the 404th Fighter Group, experienced this firsthand on March 12, 1945. His after-action report described the incident with the matter-of-fact tone pilots used when describing near-death experiences. He first saw a train with numerous cars and fired his 4 rockets into it, damaging the locomotive and setting 2 tank cars ablaze. Then he spotted a plume of smoke some distance away and fired his guns at the base of it. As he got closer, he realized the smoke was coming from a short tunnel and a train was protruding from the other end. As he swung around to make an attack on it, he saw a little red ball flash past his wing and wondered briefly what it was. He found out quickly enough when his aircraft shuddered from direct hits. 20mm rounds had nearly severed the pitot tube and damaged the bomb pylon. He made it back to base, but barely. The ground crew counted 17 separate hits on his aircraft. Lieutenant Neil Worley of the 365th Fighter Group had an even closer call on May 28, 1944. After making a high-speed pass on a German troop train, which he described as turning the locomotive into a sieve, he ran into the steel cable supporting a water tower beside the tracks. 40 feet of half-inch steel cable wrapped around his propeller. The impact should have torn the propeller clean off, which would have caused immediate catastrophic engine failure and certain death at that altitude. Instead, the massive Pratt & Whitney radial kept running. It was vibrating so badly the instrument panel became unreadable, but it was producing enough power to get Worley back across the English Channel. He landed safely, climbed out, and stared at his propeller wrapped in steel cable. The ground crew couldn't believe he'd made it back. Worley couldn't believe it either. Stories like these spread through squadrons quickly. The Thunderbolt could survive damage that would have ended any other fighter's mission. That knowledge gave pilots confidence to press attacks harder, to take risks other fighter pilots couldn't afford, to keep fighting even after taking hits that would have sent other aircraft spiraling into the ground. The statistics from D-Day forward tell the story of this campaign's scale. From June 6, 1944 to May 8, 1945, Victory in Europe Day, Thunderbolt pilots claimed destruction of 9,000 locomotives and 86,000 railway cars. These were claims made by pilots and validated through gun camera footage and ground reconnaissance, so they weren't just guesses or exaggerations. The actual numbers may have been somewhat lower. Combat claims always involve some uncertainty, but German records confirm that by late 1944, rail transportation in France and Western Germany had effectively collapsed. Trains weren't running on schedule. They weren't running at all in many areas. Field Marshal Gerd von Rundstedt, commander of all German forces in the West, complained bitterly in reports back to Berlin that air attacks made it impossible to bring a single railroad train across the Rhine. This was an overstatement born of frustration, but it reflected the genuine desperation German commanders felt watching their logistics network crumble. The true measure of the Thunderbolt's impact came not in any single dramatic engagement, but in the cumulative weight of thousands of missions flown by hundreds of pilots across 11 months of continuous operations. But if one period crystallizes the transformation, the moment when German mockery turned to desperate fear, it was the period immediately following D-Day, June 6 through August 1, 1944. During these 8 brutal weeks, as Allied forces struggled to break out of the Normandy beachhead. German commanders attempted to move armoured divisions into position to contain the invasion. The 2nd Panzer Division, stationed near Chartres, began moving toward Normandy on June 7th. Under normal circumstances, a motorized move of 120 miles would take perhaps 2 days, with units arriving ready for immediate combat. Instead, harassed constantly by Thunderbolts of the 9th Air Force, the division took 5 days to reach the front and arrived with 30% of its vehicles destroyed or abandoned and its fuel supplies depleted. The division went into action piecemeal, never achieving the concentrated armoured assault German doctrine required. They were defeated in detail, worn down by constant air attack before they ever engaged Allied ground forces properly. The 2nd SS Panzer Division Das Reich, stationed near Toulouse, received orders on June 8th to move north to Normandy. The distance was 450 miles. Under peacetime conditions, this would have been a 3-day road march at most. Under air attack, it took 17 days. Thunderbolts from the 19th Tactical Air Command hunted the division relentlessly, attacking vehicle columns, destroying fuel trucks, forcing the Germans to move only at night, often abandoning vehicles when fuel ran out. The division that finally reached Normandy had lost more than a third of its combat strength to air attack before firing a single shot at Allied ground forces. They were exhausted, demoralized, and combat ineffective before the battle even began. On July 29th, 1944, during Operation Cobra, the American breakout from Normandy, the 405th Fighter Group, encountered a German column trapped between Rancy and Saint-Denis-le-Vêtu. Elements of the 2nd and 3rd Armoured Divisions had caught this column on a road with bocage hedgerows on both sides blocking any escape. The Thunderbolts arrived at 3:10 in the afternoon and attacked continuously until 9:40 in the evening. 6 hours of continuous attack. The pilots flew multiple sorties, returning to base to rearm and refuel, then flying back to continue the attack. It was methodical slaughter from the air. When ground forces examined the site the next morning, they counted 66 destroyed tanks, 204 destroyed vehicles, and 11 destroyed guns. The road was impassable, blocked by burning wreckage and German dead for over a mile. Survivors described it as hell on earth, an apocalypse of fire and steel from which there was no escape. Luftwaffe ace Heinz Baer, who survived the war with 220 aerial victories and had fought Thunderbolts repeatedly throughout 1944 and 45, gave perhaps the most succinct German assessment. The Thunderbolt could absorb an astounding amount of lead and had to be handled very carefully. This from a pilot who had mastered combat against Spitfires, Hurricanes, and Soviet fighters. The careful handling Baer referred to meant avoiding combat whenever possible, engaging only when tactical advantage was overwhelming and never, ever following a Thunderbolt into a dive or trying to attack one at low altitude where its ruggedness made it nearly invulnerable. Major Joseph Priller, another high-scoring Luftwaffe ace with over 100 victories, was more direct in his post-war assessment when American interrogators asked him about the Thunderbolt. He admitted that German pilots had initially dismissed it as ineffective. "We laughed at them in 1943. Nobody laughs now." By 1945, Priller called the Thunderbolt the perfect fighter bomber, noting that its guns never jammed, never overheated despite sustained fire, and the aircraft consistently outmatched expectations. This represented a complete reversal of the assessment German pilots had made when they first saw Thunderbolts over Belgium in April of 1943. The reversal wasn't based on changing opinions or propaganda. It was based on hard material evidence that accumulated mission after mission, sortie after sortie. German soldiers on the ground learned to fear the sound of Pratt & Whitney radial engines at low altitude. That distinctive rumble, deeper and rougher than inline engines, meant incoming fire from 50 caliber guns that could shred trucks, light tanks, and infantry positions. It meant bombs and rockets that could destroy bridges and ammunition dumps. And it meant an aircraft that would keep attacking even after taking damage that should have brought it down, flying on while trailing smoke with cylinders shot away, with control surfaces damaged, pressing the attack, and then somehow making it back across Allied lines to safety. The numbers tell a story that transcends individual combat accounts and personal narratives. Between D-Day and victory in Europe Day, Thunderbolts flew more than 546,000 combat sorties. Think about that number for a moment. 546,000 individual missions. They claimed 3,752 enemy aircraft destroyed in aerial combat, more than any other Allied fighter type in Europe. But those air-to-air victories, impressive as they were, represented only a fraction of the Thunderbolt's impact on the war. The ground attack statistics revealed the aircraft's true role in defeating Germany. 9,000 locomotives destroyed or damaged beyond repair, 86,000 railway cars rendered useless, 6,000 armoured fighting vehicles, including tanks, self-propelled guns, and armoured personnel carriers, knocked out before they could reach the battlefield. 68,000 trucks destroyed, each one representing not just lost transportation, but lost cargo, ammunition that never reached the front, fuel that never powered an attack, food that never fed defending troops, medical supplies that never treated wounded soldiers. These weren't exaggerated propaganda figures designed to boost morale at home. They were conservative estimates based on gun camera footage, pilot reports cross-checked against squadron intelligence officers, and post-war German transportation records that confirmed the systematic destruction of their logistics network. German efficiency in record-keeping meant historians could later verify much of what Allied pilots claimed. The Thunderbolt also dropped 132,000 tons of bombs during the war, more than twice the tonnage dropped by any other Allied fighter type. These weren't precision strategic bombs dropped from high altitude against factory complexes. These were close air support missions, fighter bombers diving on bridges, rail yards, ammunition depots, troop concentrations. 500-pound bombs delivered from 1,500 feet, skipped into tunnel entrances to trap trains inside. 1,000-pound bombs dropped on concrete bridges that required multiple hits to collapse. High-velocity aircraft rockets, 5-inch unguided projectiles nicknamed Holy Moses, fired at armoured vehicles from angles that conventional anti-tank guns couldn't achieve. The cost was substantial. 3,499 Thunderbolts were lost to all causes in combat. Many were victims of ground fire, the occupational hazard of low-altitude attack missions, where every German soldier with a rifle could potentially hit an attacking aircraft. Flying at 300 feet meant you were within range of everything the enemy had. But the loss rate of 0.7%, 7 aircraft lost per 1,000 sorties, was the lowest of any Allied fighter in Europe. Thunderbolt pilots had better odds of surviving their combat tours than pilots flying any other fighter type. This wasn't luck or chance. It was engineering. The aircraft brought damaged planes and wounded pilots home when other fighters would have gone down in flames. Lieutenant Robert Bruhl, flying from K-29 airfield in Belgium in January of 1945, described the close air support missions that became routine during the final months of the war. You would have an army guy in a Sherman tank talking to you on the radio. When you appeared overhead, he would say something like, "We need you to bomb the German tank hiding behind the little farmhouse with the red roof." The problem for us overhead in our Thunderbolts was that we could see dozens of farmhouses with red roofs. Everything looked the same from altitude. The solution was to fly lower, identify the target precisely, and deliver ordnance with accuracy that required coming within range of every German weapon in the area. The Thunderbolt's ruggedness made this sustainable over dozens of missions. Other fighters couldn't absorb the damage and keep flying mission after mission. First Lieutenant Leslie Bose of the 358th Fighter Group flew 107 combat missions and walked away from 4 wrecked Thunderbolts. Each one was damaged badly enough to be written off as total losses, but intact enough to land or crash land without killing the pilot. His assessment, recorded in a post-war interview, captured what pilots came to understand about their aircraft through hard experience. This plane deserves greater recognition. The Thunderbolt was one of the most important factors in winning the air war over Europe, yet it has never received the credit it deserves. The sleeker P-51 Mustang got the publicity, the romantic image, the post-war glory. It was photogenic. It looked like a fighter should look. The Thunderbolt did the brutal, unglamorous work that actually defeated German military power. It destroyed the locomotives. It interdicted the supply lines. It made German mobility impossible. And it absorbed punishment doing work that would have destroyed more fragile aircraft. By April of 1945, as Allied armies closed in on Germany from east and west, German rail transportation had effectively ceased to function in any meaningful way. What locomotives remained operational had no fuel to run. What fuel remained available couldn't be transported because the rail lines were cut in hundreds of places. German armies couldn't maneuver, couldn't concentrate for counterattacks, couldn't retreat in good order when necessary. They were fixed in place, supplied by horse-drawn wagons when they were supplied at all. and defeated piecemeal by Allied forces that retained complete mobility and unlimited air support. The irony of the Thunderbolt's success lay in how completely it validated a design philosophy that looked wrong to everyone who first encountered it. European air combat doctrine, refined through years of bloody experience, emphasized lightweight, nimble fighters optimized for turning combat at medium altitude. The Thunderbolt was heavy, relatively unmaneuverable in turns, and optimized for high-altitude performance and diving attacks. It violated the conventional wisdom that everyone agreed upon, and it worked better than anyone expected or predicted. Alexander Kartveli, the engineer who designed the Thunderbolt, never claimed to have created an aesthetic masterpiece. He never said it was beautiful or elegant. He claimed to have solved a specific problem: how to build a fighter that could escort bombers deep into Germany, fight effectively at altitudes above 25,000 feet, and survive the combat damage inevitable in hundreds of missions over enemy territory. The solution required accepting trade-offs that European designers rejected as unacceptable. Accept the weight penalty of a large radial engine to gain survivability. Accept reduced maneuverability to gain high-altitude performance. Accept an ungainly appearance to fit the necessary turbo supercharger system inside the fuselage. Every design choice that made the Thunderbolt look wrong was actually correct for the mission it had to perform. Europeans had optimized for the Battle of Britain. Americans had optimized for something else entirely. The transition from escort fighter to fighter bomber revealed another layer of the design's hidden strengths. When 9th Air Force commanders needed aircraft for ground attack missions in 1944, the obvious choices seemed to be light bombers or attack aircraft purpose-built for that role. Instead, they discovered that the Thunderbolt, designed as a high-altitude interceptor, was better suited for low-altitude ground attack than aircraft specifically designed for that mission from the beginning. The shift to ground attack missions in 1944 required developing entirely new tactics. Ground targets didn't maneuver like aircraft, they shot back differently. The threats were different, and so were the techniques. Attacking a train required approaching low, identifying the locomotive, descending to attack altitude, firing at the boiler, and pulling up sharply to avoid the train and surrounding terrain. The attack lasted seconds. Everything had to be perfect, or you'd miss, or worse, crash. Pilots practiced on British trains during training missions, practicing the dive angle, the firing solution, the pull-out timing. British railwaymen complained about American fighters making